Jupiter's atmosphere material, and it formed something like a mushroom cloud, almost like a nuclear explosion, and we were able to watch this happen. And eventually, it left scars in all the places where the fragments hit on Jupiter, and those fragments actually, some of them lasted for as long as a few months. Now, I hope all of you heard, but at least some of you probably heard, that the comet just hit Jupiter a couple of weeks ago. We are actually right now in the middle of commissioning Hubble after the last servicing mission, but these are such unique events that we actually stopped all activity and watched it. I mean, actually gave time for Hubble to observe it. We've never done something like this in the middle of orbital verification, but here it is. And we observed the spot. Here is all of Jupiter. Here is the spot. You can see how similar it is to previous hits from this. In this case, this was, of course, discovered by an Australian amateur who first discovered it, but Hubble gave this very high-resolution image of this impact of this thing, and we actually have a couple of more visits to see this as this thing is going to spread out. So this is really literally hard to see the observation, the impact happened July 19th of this year. Stellar life and death, very quickly. This star brightened up in 2002. It was a large pulse of light. Light from it propagated, and as light propagated, it illuminated farther and farther regions. So this is what we see here. Nothing is expanding here. It's just light propagating and illuminating the surroundings. We observe this every few months, and this is what it looked like. We observed it now 7 times. This I showed you 5 here of this star P8381. When stars like the Sun die, they form these beautiful shapes we call planetary nebulae. I'm just showing you a few images. This is the Eskimo. This is Cat's Eye. Absolutely stunning images of this thing. The Ants Nebula. And this, when more massive stars explode, this is the Crab Nebula, the result of a supernova explosion in the 11th century, was actually observed by Korean, Japanese, Chinese, and Native American, let's call them astronomers, or at least observers of the time. Just before servicing mission 4, we took a few images with our own workhorse, Wide Field Planetary Camera 2. I just want to show you those. So here they are. This one we call Fountain of Youth, both because this looks like drops of water, but also because these are actually clusters of very young stars. This was, some of you may know about our You Decide contest, where we asked the public to vote on one of 6 targets that Hubble will observe. This was the target that was chosen, and we observed it, and it produced a spectacular image. This is one of the very last images taken by Wide Field Camera 2, and this is an image taken after we have this electronics board that stopped working, and for about a month the telescope wasn't working. When it came back to life, I suggested observing this because I already saw in my head the title we would give to this observation. We say, upon returning to work, Hubble scores a perfect 10. With that image of actually 2 colliding galaxies. This galaxy was actually completely stretched into a spiral that formed these images. Now we have this servicing mission, and I'll just show you 3 or 4 images from that. Here is a very unusual sight. Because of the perceived risk to a mission to Hubble, 2 shuttles had to be on launch pads at the same time. This is something that, does not happen in launches to space station. So 2 shuttles ready to go, both Atlantis and Endeavour. The shuttle launched. I was there. It was absolutely gorgeous. And these are the astronauts working on Hubble. The person here is John Grunsfeld, who has been to Hubble 3 times. So he's the real Hubble hugger. He's the person who actually got to hug Hubble quite a few times. And then they released the telescope, and this is the picture of the released telescope just immediately after the shuttle released it back into orbit. And the shuttle, of course, landed safely, and we had the astronauts, the crew, visit us last week. So they've installed 2 new instruments, they have repaired 2 existing instruments. Hubble has actually its largest complement of working instruments it has ever had. So of course we're looking for all of these to be continued. Thank you.
Bravo.
I was curious, when you look at globular clusters and ask about their dynamics, is there any particular interesting metric for dark matter there to play a role in the dynamics of globular clusters? Is the smaller scale measure interesting?
Not particularly about dark matter. I mean, there are interesting things about them. First of all, they are some of the oldest objects in the universe. Second, they may harbor intermediate mass black holes. And in fact, there has been a suggestion already in 2 clusters that maybe one such black hole has been observed. Usually, when observed closer, those turned out not to be true, or at least not certainly to be true. So, in terms of dark matter, there is dark matter, of course, surrounding all structures that form, but there is nothing particularly more interesting about dark matter around globular clusters than there is around galaxies and clusters of galaxies.
One other question. When you observe an infrared with Hubble, will that give you a follow-on correlating database between Hubble and the Webb telescope?
Yes, well, with some luck. You see, the James Webb Space Telescope is currently scheduled to be launched in 2014. Hubble Space Telescope is scheduled to work for at least 5 years following the servicing mission, which brings you to 2014. But everybody agrees that if the instruments will work perfectly, there is no reason not to extend Hubble's life to, 6, 7, 8 years. So we may even have a potential for overlapping of the 2 telescopes, and then we will have fantastic coverage all the way from ultraviolet to, the farther infrared, because Hubble is still very near infrared. The James Webb Space Telescope will go into the mid-infrared, so this will be absolutely outstanding if it will happen.
And you would then have the opportunity to cross-calibrate the 2 instruments, I presume.
Well, it's not just a matter of calibration. I mean, there are some things where you absolutely need this coverage to see everything that's happening and to tell you about the physical processes. It's like the difference between our eyes seeing only the color green or seeing all the colors that we see.
Great talk. I just had a quick question about the beginning of your talk about speaking of dark matter. You had mentioned that we don't really know what it's composed of, but there may be some exotic particles that it may be composed of. Are there any leading macho or Webb candidates for that?
Yeah, so the leading particle candidate for dark matter are things we call neutralinos. These are the lightest, stable, supersymmetric particles that have been suggested. And these particles, in principle, could be discovered in the Large Hadron Collider, but the energy may not quite be sufficient to actually discover them. So we will have to wait and see. There are other candidates, but this, I would say, is the leading candidate for dark matter.
Thank you.
Any other questions?
I have one. Speak loudly. Can you hear me? Just speak loudly.
Yes.
I have a question regarding the, first of all, I should announce that I am not a technician in any sense. I'm from the mathematics community as opposed to scientific. There are several things about our current interpretation, if I understand the interpretation